Today we are going to learn the part of serverless computing that is offered by Microsoft Azure with Azure Function apps. So the session begins with what exactly is serverless architecture, why serverless architecture is so important these days, followed by implementing the serverless functions using Azure Functions, where we are going to see the information about the triggers and the bindings for the function, where triggers represent the event-driven implementation for a function, and the bindings is all about how do we give the input to the function and how do we take the output from the function. Then we'll talk about how to create Azure Function apps using Visual Studio, and followed by how to implement Azure Durable Functions. So let's focus on the first topic here. What is serverless architecture? So basically, when we talk about the serverless computing, it's not about having no servers in place. Servers, the hardware definitely is going to be required. The softwares are also going to be required. It's more about you as a developer are not supposed to be concerned about how do I deploy those servers, how do I set up those servers, and how do I make them ready, then how do I host my code so that it can be accessed by my clients. And I just focus on my business logic over there, which needs to be catered as per the application's requirement. So we can just summarize this as it is a cloud computing execution model in which cloud provider manages the server and allocation of various machine resources. Along with that, the pricing is also a factor over here, where this serverless computing basically is quite different from the other computing models that we have. So the pricing over here is based on actual amount of resources that are consumed by the application instead of predefined units of resources. This is where we can have a straight comparison with typical Azure App Service to start with. When you go for Azure App Service to host any web application, before you actually deploy anything on the app service, you need to configure something called as app service plan or app service environment. And what exactly that app service plan or app service environment decides, it's somewhat related to what kind of hardware resources I'm going to use for my application, like how many CPU cores I'm going to need, how much RAM I'm going to need, how much storage capacity I'm going to need to host my web application. This is where we predefine the set of resources that we need while working with the app service. So whether I deploy any application later on after defining the app service plan or not, my consumption is going to be considered over there as if I'm using it and I'm supposed to pay for it. So if app service plan is created today and let's say it kept on running for next 30 days, 24 by 7, I would end up paying the cost which was mentioned while buying that app service plan at the beginning. And while coming to the actual cost that I would be paying, it will not be considered whether I actually utilize those resources or not by deploying some applications into that app service plan. So this is where probably I would be ending up wasting some of the resources and some of my money as well, where I'm not utilizing the resources, I'm still paying for it. And that's where the extension to the platform as a service comes in the form of serverless computing, which says that my pricing will be based on for how long the code actually executed and whatever the resources I have asked for that particular code, the billing will be always pro rata based. It will not be like I need to reserve some of the resources for my serverless compute. It will be always based on exactly how much usage was there at what time. And hence, I can reduce the amount of money that I would be spending on my on the execution of my code. Suppose you create a app service which hosts web API created using .NET Core or something. If you are hosting it as an app service plan only, in that case, actual calls probably are happening for say 2 to 3 hours. I mean, the execution of the code is happening for max 3 hours, let's say, but I would still be paying up for the complete 24 hours. Now, if it is some functionality that I'm running in the backend, ideally, I should be paying up for only the amount of time when the actual execution happened. So this is what the capability that is added to the platform as a service by the serverless computing model. And Azure has adopted that with the help of Azure Functions. So here, ultimately, you need not deploy or manage the underlying virtual machines. Even the applications that can be acting as the host for the functions also, you don't need to worry about that. It is just the code that you would be worried about, and that's the code that you will be deploying directly. You don't need to create any host, you don't need to manage any host. You just need to tell what amount of resources you want for that particular Azure function to work, and you just deploy the code directly into that Azure function. Right, so function apps probably can allow you to host more than one functions at the same time. And there, once again, your focus is going to be more on deploying the individual functions to the function app, where function app is just a logical unit. We cannot say it's going to be the billing unit as well. The billing unit will be ultimately your code which is running at any given instance of time. So what all things come into the serverless architecture over here? That will answer our second question as well. Why serverless architecture? One of the reason I've already spoken about the pricing, how it is calculated over here. And then there are a few more things like you get the modular and flexible implementation here. And how we say that? Because here, all of your code is going to be individual function. And that function can be having the atomic code running into it, and that can be consumed by any application at any point in time doing whatever that we are looking for. Now, here there is a design consideration also that you need to keep in mind. Like any function should not have too big code or too much amount of operations being done into it. You have to design the function in such a way that it contains only atomic unit of implementation into it. And here we can basically think about more on the role-based functionality being written into the functions implementation. So say, for example, I may have a function which is just calculating the interest for my loan account. There can be a function which is just uh, helping me out to insert some data into some database table. That can be a database table in RDBMS, or that can be the data being put into some NoSQL database like Cosmos DB or something, right? So you have to decide the role for each and every function that you write, and that function should take care of only that type of functionality. So we are focusing once again on something called as separation of concerns, clear separation of concerns, just like how you design your web APIs. The similar kind of design considerations come into this. And ultimately, this Azure Functions programming model or serverless architecture programming model puts more emphasis on the microservices as well, where if you consider the design considerations for microservices, they are pretty much the same what Azure Functions are asking for. You have to have the separation of concerns as the top priority, and you must have as atomic code into your functions as you can. You have to break down your complex requirements into simple requirements, and then for each simple requirement, you need to have a separate function created. And if required, you can chain those functions with each other so that your overall implementation goes the way how you are looking for in the complex manner. But at the same time, the implementation at the function level is so atomic that the maintenance and the management of those functions and the testability of those functions is not at all hampered. If you want to make certain changes into one of the function, you just make those changes into that function and use the test cases against that function only. The rest of the functions will be totally independent of what you have done with this particular function. So that is something which brings in the modularity and the flexibility in terms of implementation. The next thing that comes over here is functions are event driven. What that means is they are callable based on some sort of event or what we call as triggers. Now, the functions are not something like which will be executing on their own or something like that, though that can be done with the help of the schedulers and all. But ultimately, when you use scheduler, there is some sort of event which is happening. So the events can be something like there is some HTTP request coming in to which you need to respond with HTTP response. The function can be triggered by a message arriving in the storage queue or maybe the service bus queue. The function can be triggered based on some event coming into event grid. It could be some storage trigger as well, which probably looks for some entry being made into the file storage or maybe into the blob storage. It can be something based on timer schedule as well, as I said before. So functions are always going to be event driven. Even if they are automated for execution, they will be done with the help of some timer or schedules. And hence there also they are going to depend on events. So typical event driven programming model they bring in and they wait for the event to occur before being executed. And then ultimately the pricing once again comes as pay per use. So based on how many times the function executed and for how long it was executed, you will be calculating the price that you will be paying against that function utilization. And ultimately, the last point that comes in over here for the serverless computing is scalability. Now with scalability, there is another important feature that we need to discuss over here. Every function or every piece of code that you are going to run for any particular client's request, it will be actually running completely on disparate hardware or discrete hardware and the virtual machines completely unknown to the client. And this is something which basically takes your automatic scalability to the next level, right? Because for every request, there will be the assignment of new hardware resources, and this hardware resource is going to be supplied by some virtual machine. So if two different requests coming for the same function from two different users at the same time, they won't be taken care of by one single virtual machine or one single set of the hardware resources. For both the requests, there will be different virtual machines allotted, which means different hardware resources will be allotted, and your request will be carried out accordingly, and you will be charged accordingly. So in that particular case, the scalability automatically comes into picture, and that takes your platform as a service implementation to the max level for better and optimized scalability than the traditional PaaS services. And what I mean over here is there will be multiple instances of your function running for the multiple requests that are coming into your Azure platform. Okay, so that is something which basically defines what is serverless architecture and why serverless architecture is important going forward. We need to focus more on the code. We need to focus on getting that code up and running as soon as possible. We don't want too complex code always. We don't want a lot of changes to be made to the very complex implementation always just for a simple change request or maybe just for issue fixing or bug fixing. We are looking for some simplified implementation over there, and that's where the serverless architecture actually helps us. So let's see how do we implement the serverless architecture with Azure Functions. Do you think that all the Azure Functions are actually serverless? The dependency over here has to be more on setting up that function itself. It's not about the function having a dependency on some code component which is running inside some virtual machine or something like that. The function may or may not have such kind of dependencies, and that doesn't have anything to do with the serverless architecture. The function itself still can be a serverless architecture, even if it depends on a component that is running in a dedicated virtual machine, because the function itself is not something which is running in a virtual machine or a dedicated virtual machine or some app service or something like that. Here, we just need to focus on the function, how we are deploying that function. While deploying the function, are we setting up some app service environment or app service plan or something? Are we deploying that function code into some virtual machine, dedicated virtual machine or something? We need to take care of all these aspects. If we are not doing any such things, basically the function code itself is getting deployed somewhere, which may be the source code, which may be the compiled code. But if only the code is getting deployed without worrying about where it will be actually hosted, whether there will be app service plan or not, app service environment or not, we actually say that the function is a typical serverless function. So that we will get to know once we start deploying the function, or I would say creating a function deployment on Azure. So let's go to the browser where we need to browse to the Azure portal, which definitely needs a Microsoft account. And along with that, we need to have an active subscription, Azure subscription, mapped to that particular account. So I have one such account, that is Saket Karnik at hotmail.com, already logged in on the machine. Hence, it directly lands on the portal. And here I directly go to the main menu and click on Create a Resource, where what I'm looking for is function app. Directly in the popular category, it shows me the function app here, or else I can also go for compute, and here also I see the function app. That's the right category for function apps. And why it comes into the compute category is because the function app basically run on their own with their own environments that are set up by the cloud provider behind scenes, right? So compute gives me the function app template. Here I need to select my subscription in which I want to do the deployment, and then the resource group. I'll create a new resource group over here for this session. Let's say this is named as demo-rg, and then I need to give a function app name. Here I'm not going to actually create the functions. It is just the container in which more than one functions can also be deployed, and the endpoints can be provided to those functions individually. For that, we need the function app as a container to be created. And the name that you give over here has to be globally unique, as the name that you give here becomes the global available subdomain under Azure websites.net. So let's say the name of my app is OI demo function app. This name is available, confirmed by this green tick mark coming right next to this function name. And then here I have an option how do I want to publish my function apps. Whether it is going to be the code that will be deployed, that code can be source code, that code can be compiled assembly. As a DLL, I can deploy that if I'm defining that function or creating that function into Visual Studio. Or else I have the option of deploying my functions to the Docker container as well. If I'm looking for platform independent version of functions, and probably I've created and deployed those functions already into a Docker container, probably because I want that Docker container to be deployed across the platforms, then I have the option of deploying the complete Docker container here. So I say code, and then I need to select an important aspect, that is Runtime Stack, where basically I have the support for 5 different runtime stacks, that is .NET Core, Node.js, Python, Java, and PowerShell Core. So what that means is I have the choice of languages that can be used for coding the Azure functions. When I say .NET Core, any language that is supported by .NET Core like C# or VB or F#, these are all supported with this runtime stack of .NET Core. Then Node.js gives me the support for JavaScript. Then Python, by the name itself, it is clear it is for Python language, followed by Java language, and then PowerShell script can also be used to create the code for the function apps. So for now, I'm going to select .NET Core. The runtime version I need to select for .NET Core. Here it says the only available version is 3.1. This is the current latest stable version or long-time support version officially by Microsoft. So the function app definition also has been modified to target .NET Core 3.1 version. And then where I want to deploy, in which region, on which data center I want to deploy this. So here I go and select Southeast Asia. This can be based on where your audience of the application actually is. The nearest data center you have to pick up. Click on next, and then it is talking about, in fact, asking for a storage account to be created. Why the storage account is required is because any storage account integration, if your function uses later on for any storage events, the storage account will be required there. Beside that, the code that you deploy, whether it's DLL or the source code, needs to be stored somewhere on the server as well. So for that, the storage account once again required. So it's a mandatory requirement here. And I'll say create a new storage account for me by the name OI demo storage. Click OK. And then it is asking about, because it's a .NET Core runtime stack I have selected, the .NET Core code can run on Windows or Linux environment. So it's asking which runtime stack you want to use. For now, I just keep it Windows, though it can be Linux as well. If you have compiled your .NET Core code for the Linux platform, then you have to choose the operating system as Linux. Then comes the plan type, which is where you decide how you are going to pay and how much you are going to pay. So this is where we have 3 options like app service plan, then premium, and then consumption. Against consumption, we have option mentioned as serverless. What does that mean? If I go for app service plan, my function app will be hosted as the part of the app service plan. And that means the app service plan needs to be created. And I will be paying for 24/7 policy for all the number of days till when that app service plan was active. Just like any web app that you deploy on app service plan. Right? In that case, my Azure function is not going to be considered as serverless compute or serverless architecture based implementation, because I'm reserving the resources over there and I have the hosting environment available over there where I'm going to inject my function app for the hosting purpose, where the function app will not create its own host. It will basically use the host provided by the app service plan only. Okay. Then comes premium, which is like app service environment, where you have more dedicated resources available for app services. So very much similar to app service plan, but then you have the isolated tier available where the isolated tier says that this particular premium plan can have only one and only one function app deployed into it, though that function app can have multiple functions into it, but more than one function apps will not be allowed to be deployed. So more restricted and more reserving in nature, and this also comes at a high cost compared to app service plans. App service plans provide you much more cheaper options because they don't consume the resources all the time. There is a timeout for the app services. If your app service is not running for some amount of time, the resources are automatically released to the resource pool. Though they are not completely released, they are still reserved for your requirement only. But then the other applications running in the same app service plan can utilize those resources. So now how do I decide whether I use app service plan or premium service? Premium service is usually not for the Azure functions. Usually for Azure functions, you will be going either for app service plan or consumption plan. Now, the question comes once again that what consumption plan means. Consumption plan is where exactly the pricing is calculated based on how much usage was there and for how long that usage was there. So totally pro rata calculation is done for the billing purpose. And that's what basically which represents the typical serverless implementation. So how do I decide whether I should be going for serverless or not? Or in other words, consumption plan or app service plan. So the idea is simple. If you have only the function apps created and deployed, and you are just the service provider, so you are creating more and more functionality in the form of function apps, and there are clients who are consuming those function apps, and the clients are basically the third-party apps created by third-party organizations. In that case, you can straight away go for the consumption plan. But if you have multiple applications already being hosted into your account, and those applications are based on app service plans, and there is a lot of underused usage for app service plans, then probably you can decide the function apps being hosted on app service plan so that you can optimize the usage of the resources consumed by app service plan. We'll go with consumption plan over here, and let's click on next. It's all about the monitoring part. So just like any other .NET apps these days, we have the application insights, the cloud-based that is provided now for every .NET applications, that is application insights. So the same thing can be activated and configured for the function apps as well. And even if you don't do it right now, it can be activated later on also by going to the configuration for the function apps. So for now, I'm just keeping it disabled. I'm not looking for app insights to be used as of now. That makes the deployment also a little faster. And then click on next. Tags are required if you have too many resources in the same subscription and with the similar or matching names. That can create confusions in terms of identifying the resource. That's where you make use of tags. As right now, I don't have too many things deployed. Especially the names are also very different for whatever resources I have already deployed. Hence, I can leave this tags information empty and I can just go to next. Here it shows you the summary of what you have configured so far for the deployment of function app. So confirms the subscription ID, the resource group where it is deployed, the name by which it is deployed, Runtime Stack, .NET Core 3.1, then storage account that is going to be used, then plan type, which confirms consumption plan being used, then by what name the plan will be created. So it is ASP demo RG, V162 something, and then operating system Windows region as Southeast Asia and SKU is dynamic, and ultimately the application insights are not enabled. Let's click on create. This deployment, as I said, will not create functions. It will just create a container in which I can deploy my functions. And the billing will not be about this container. Billing will be about the function itself that is going to be deployed later on. And how many times the calls are going to be made, and how much resources that function call is going to use. So based on that, pro rata I'll be billed. So the deployment is underway. Soon it will be completed, as this is just the configuration of the function container named as function app is getting created. It doesn't take too much of time, and it's completed. So here I click on go to resource, go to my function app deployment, and here it shows me the main endpoint, the base URL for the function app service, and under that, whichever function that I create will have its own route map to this particular base address itself, just like web APIs. And here, if I click on functions on the left hand side, it shows me there is no function that is deployed as yet. I need to proceed and deploy the functions one by one. So as of now, it's just the function app as a container that has been created. There is no single function deployed into it. So let's go ahead and click on add. Here I have the option for on what basis the function is going to be executed. The event needs to be selected there. So we have HTTP trigger. HTTP trigger means the event is HTTP request to be received. Once the HTTP request is received on a certain route, automatically the function starts executing. Similarly, we have timer trigger where we need to give the schedule when that function will automatically be triggered. Then we have Azure queue storage trigger. So this is storage queue. Whenever there is a message that arrives, or whenever the message that is read from that particular queue, I want the function to be triggered. This is where the Azure queue storage trigger comes in. And then the service bus queue trigger does the same thing for service bus messages. Then we have the similar thing for service bus topic trigger. And then we have blob storage trigger. Then we have event hub trigger. Any event that is occurring into the event hub, we can actually select which event we are looking for. And the moment the event hub receives that event, automatically my function corresponding to that event will start executing. Same way, we have Cosmos DB trigger as well. So if any operation within the Cosmos DB database being done, the trigger fires and that makes my function execute in response. The same way, we have IoT hub trigger as well, which also talks about event hub. In fact, based on event hub only. Then we have SendGrid trigger as well. This is the SendGrid is a third-party service for sending bulk emails, and whenever the email item is added to the particular queue, automatically the function gets executed. Then we have Azure Event Grid trigger. Then we have durable functions, and these remaining three things are durable functions, and the final one being signaler for callbacks. So for now, we are going to proceed with the HTTP trigger here. We'll name this function as OI demo func, and then I need to configure the authorization level, the security, which decides who can make the request to this particular function and who cannot. If I say anonymous, that means anyone having the URL can make the request to this particular function. If I say function, that means the request needs to contain an authorization header containing the security key for the function. Only the request coming with the valid security key will be entertained by the server. The others will be rejected with unauthorized access response. Then we have admin as another authorization level. That means only admins or admin users can make the calls to these functions. The other users, even if they have the key, will not be able to perform any request on this particular function. So for now, we will keep it function, and let's click on create function. This will bring in a sample function for us. and the function is created, where it shows some configuration about that function, in which function app it is created, what is the status, which resource group, which subscription ID. This is all about the host environment, in this case, which is the function app. And then we have option for get function URL as well, which allows me to see what is the URL to invoke this function. And this automatically includes the code which represents my security key to be able to call this function as well. So I copy this URL, click on OK, open new tab over here, paste that URL here, and press enter. It says that this HTTP triggered function executed successfully. Pass a name in the query string or in the request body for a personalized response. What it means is it's waiting for a query string parameter by the name, and where it will be doing some kind of processing on it. Either you pass that name as the query string or into the request body. So using the browser, we can pass it only into the query string. So here we go to the address bar. Here we see there is query string already built, code equals to security key. So I'll just put another key over here with ampersand name equals to, let's say, Saket. Enter. And here it shows me, hello Saket, this HTTP triggered function executed successfully. How about executing this function with the request body having the name? For that, we need to create the HTTP post request, for which I will take help from the web debugger, that is Postman, though you can use other debuggers like Firebug or Fiddler, whichever you are comfortable with. Just clear all the prior requests over here and then click on plus new tab. And here, first I want to test with the get functionality only. And here I put my URL, which was copied from the browser. So it already has got the name query string parameter with the value as Saket. And I click on send just to see whether I'm able to send the request successfully from Fiddler also or not. And I am able to. I get the response here. Now I want to create a post request over here where this query string parameter is of no use. And while going for the post request, the first thing which I need to do is I need to set one header, that is content type, to application/JSON. Then I go to body, where I select the type of body as raw and the format as JSON. And there I say the JSON body looks like name enclosed in double quotes and the value enclosed in double quotes. So let's say this time I put a different input so that we can differentiate, and I click on send. I get the response, hello Saket Karnik, and the following text, this HTTP triggered function executed successfully. So this is a default implementation that we have over here. Just one thing, if I don't mention the security code here and click on send, see what happens. It simply gives me status code 401 unauthorized. Here you can see that. And there is no response actually. If I want to see headers, here it shows me the headers, the response headers, the cookies, body is nothing. And if I'm looking for the text raw, there is no response actually. It is just the status code 401 unauthorized that has come back. Now I want to see what code actually is driving this function. So here on the left hand side under developer, I click on code plus test, where it shows me the code editor, and I can see the complete .NET Core based code implemented on this. So let's see what it is doing. The first thing, it is logging the information. C# HTTP trigger function processed the request. Then we have some code where the variable of type string named as name, taking in the input from request.query name. So this is where it is reading the query string. The value may or may not be there. That we will check in the subsequent statements. Meanwhile, we are proceeding and defining another string variable by the name request body, where with the help of stream reader, we are actually reading the request body, and we say read to end async. So complete body automatically is parsed, and the returning string is assigned to request body. That will be the JSON formatted input. And then with the help of JSON convert from newtonsoft.json package, we are saying deserialize object request body. So the string that is passed over here automatically converts that data as JSON object. So that becomes an object now. And there I can say data.name to read the name property that is coming as the JSON object from the client side. Now, this is where we have some conditional check. If the query string parameter name has got a value, so name equals to name. If this is not null, there is a value that will be assigned directly to the name, or else with the ternary operator, we are saying go for data.name. And there, once again, we check if data is not equal to null. This question dot operator basically checks for null. If data is null, just return and assign null to this name. If data is not null, then proceed and read the name property from it and assign the value of name property to this name. And then furthermore, we are once again checking string dot is null or empty name. If it is null, in that case, we return the string. This HTTP triggered function executed successfully. Pass a name in the query string or in the request body for a personalized response. This is what we got for the first request when the query string parameter was not passed and the request body was also not passed in the browser. But then if it is not null or empty, we are proceeding and displaying hello concatenated to name, whatever the name value we have given, either as query string or as the request body. And then further string is this HTTP triggered function executed successfully. And then this is the response message we pass to OK object result function. Now what this OK object result represents? The data, of course, that is being passed. Along with that, it returns the HTTP status code 200 also. OK means HTTP status code 200. And it's not only the status code, we want the object result also to be passed. So we say OK object result along with the object that needs to be returned back. Hence the message also goes back. Now just one requirement over here, simple requirement I have. I don't want the data to be taken from the query string. Hence I comment this out. I want the data to be coming only from the request body. So here goes the code for reading the data from request body, deserialization. And here I just remove this ternary operator name question mark question mark. I directly say read the name property from data if data is not null, and then proceed with the further stuff. So after changing the code, do you realize that ideally this function should be callable only with HTTP post request and not with HTTP get request? Because that's how our code has been written. And how do we do this in web APIs? We have the attributes like HTTP get, HTTP post, etc. If I put HTTP post on a web API method, by default, the method is callable only via HTTP post request. Any other type of HTTP request will not trigger that particular function that is marked as HTTP post. Now I have made some changes, so I click on save over here. Then I click on test run. I can actually test this application or this particular function code right in the browser without Fiddler or without the separate tab into the browser as well. So that is another option that we have. Now here, the test UI comes up where it allows me to select the HTTP method. Now by default, it is giving me get and post both the options. If I put get over here and I don't add any query parameter as I'm not reading anyone, and let's say there is no body as well, and I click on run, what it would do? It would just go to this part, right? This HTTP triggered function executed successfully. Please pass a name in the query string and so. Okay. In fact, not. Here it says internal server error HTTP status code 500 because my function now is not having any HTTP GET request processing, right? So here I'm not able to proceed. So what to do? I just say close here. I click on test run once again. I go to input tab. I change my HTTP method to post. And here I say the input is this name Azure. Click on run. Wait for the response. This should have worked. I'll just say string name. And we will test it again for both the things, get and post. So if I go to get request and click on run, I get the response, but it will be like pass a name in the query string or the request body and so on, which is also not correct. And then I go for post and I put the input into the request body section like this, and I click on run. And here I get the response. So ideally, as per the changes which we have made into the code, the GET request should not be supported at all. And accordingly, this message also should be changed. Pass a name in the query string, I'll remove. In the query string, or this much I'll remove. I'll say, please pass a name in the request body for a personalized response. This is the right thing now, as per the changes we have made. I click on save, and I want, when I go to test run, here in input, it should show me only post and not get. How do I change that? For that, we go to, I have a drop down directly for looking at the code which is there into the different code files. So run.csx contains this code which is visible right now. I'll select function.json. That allows me to see some configuration regarding this function. Okay, now here you can see there is a section called as bindings. Under bindings, I have auth level function, which we said earlier, so that it requires the security key. The name of the parameter that represents my request is REQ, and that's what I'm able to use to read from the body or read from the query string. Then type is HTTP trigger, which means that, okay, the request has to be HTTP request. The direction is in, that means it's basically the input binding being configured. And then we have a section called as methods, which has got an array configuration wherein there are two values, get and post. I just remove this get and comma from here. I leave only post here and click on save. Okay, and switch back to my function code. So run.csx, and I click on test run now. Once again, here, if I see the drop down for HTTP method now, this takes a while to get refreshed. I'll just refresh the whole browser. Let's click on test run once again. Okay, let's confirm if that change was saved or not. I'll go back to function.json. Yes, it is. It takes a bit of time to actually get it reflected here. Let's close and let's wait for a few seconds more. Let's click test run once again and see the get option has gone from here, and now I have only post, which means I cannot place the get request from here. And Then if I click on run, the response comes back to me. So even if I use Fiddler or Postman or Firebug or the browser to create a GET request, it will simply let me know that the GET request is not allowed for this function. We'll try that shortly. So once again, I click on get function URL, copy the function URL, open a new tab in the browser. This anyways creates a GET request. I press enter and it says this cannot be found. HTTP error 404 says that the request cannot be processed straight away because there is no handler on the server side which can be mapped to this request and process the request further. So the only way to invoke this function now is via HTTP post request. So let's modify this function, or maybe we create one more function here where we want two numbers to be taken as input as the request body, and the addition of those two numbers needs to be returned as the response. So let's see how do we do that. So I'll go one level back over here. Let's close this blade. Okay, it just comes to the portal directly. I'll click on this UI demo function app directly. So it comes to the functions dashboard. And here I click on functions once again. Here I say add one more function for me. Again, HTTP trigger based. I'll name this function as by add func. Authorization level once again is function. I'll say create function. Function gets created, the dashboard opens up. I just go to code plus test here. First thing I do is edit the function.json because that takes some time, where I remove this get. At any point in time, I can come back and I can add this get once again. This is just like that attribute that we put in web APIs. Save this and then switch to run.csx, where I don't want this statement. First of all, request body is what I'm looking to read. Same way I'll be reading. Then here I get rid of this name. I'll say I have a variable named as a of type integer, where I want to assign data question dot n1, assuming that the request body will contain a parameter by the name n1, where question dot represents the null check for data. If data is not null, then n1. Otherwise, it's a null value. And for that, I make it a nullable int, because the null value may also come. Same way, I say there is another nullable int b that is assigned to data question dot into. I'm assuming there is another number that is into that is coming as the request body. And then here I put the if statement. It checks n1 dot has value and n2 dot has value. Both have the values, they are not null. And there I want to calculate the sum. Let's say here I have int sum assigned to 0 to start with. And here I say sum is equals to n1 dot value plus n2 dot value. And then the response message I'll prepare here. sum.toString, or maybe we can have a formatted string, dollar, that is string interpolation operator, the sum of numbers is sum. And then once again, I say return new object result response message. Made a lot of changes. Let's click on save and click on test run. The only method supported here is post as of now, though it's not have taken that yet. We need to refresh the definition a few times. Let's say refresh. Click on test run and check. Yes, the post is there. And then here I say the first parameter is n1 with the value as 20, comma. Second parameter is n2 with the value as 10, and I click on run. Let's wait for the response. A plus B here, not n1, n2. Save. Input and run. Yeah, so here we have the output. And this is how the function is working for me. The code that we write over here depends on our application's requirement. This can be some database driven code also. There are a few things which will be challenging over here though, like if we are having some external dependencies, if we are writing the code in the code editor in the browser itself, in that case, the DLLs we need to explicitly upload to the working directory of this code by using the kudu tool. And then we have to use #r statement here to load the external DLL reference here, just like how newtonsoft.json has been loaded. So by default, function app has got the newtonsoft.json.dll uploaded into its working directory. Hence, we were not required. But if any other third-party DLL we use, let's say, for example, we use entity framework or something, the DLL we will be required to upload explicitly to the working directory by using the kudu tool. And that can be a challenge at times because deployment will not be that very much smooth. And also, in case if we are using the complex implementation like something based on entity framework where we might be using some third-party libraries as well, my code will have too many dependencies, and again, I may not want the entire code to be written into the same function. I may be looking for some helper functions as well. So in such cases where the complex requirements is there and I have too many dependencies to take care of, it would be better if we create all this functionality with the help of Visual Studio, because in that way there is no challenge. Just how you use dependency management in regular Visual Studio based applications, you will be using the same skills, same tool set to work with the dependencies for function apps. And then ultimately the compiled code you would be uploading as a package to the Azure Function app. There also you have choice for going for the consumption plan or app service plan or premium plan as per the need. And that will give you much easier implementation for the management and maintenance of this particular code. Right, but before that, what I want to show you is, suppose if I'm not looking for this response to go to the user directly as a HTTP response. Rather, what I'm looking for is this function to return just a simple string that gets returned to some storage queue. Okay, so for that, I'll open another tab and browse to portal in that tab as well. I'll go to select create a resource. There I'm looking for storage service. In fact, storage, in fact, we already have created one storage, so we can directly go to resource group, demo RG, and here we can find there is storage account also created. UI demo storage, I just select that. I don't want to create a new one. And here, what I'm looking for is to see if there is any existing queue already there. No, I want to add a new queue here. Let's say by the name demo queue. And what I'm looking for is the output of that function to be returned to this queue for the further processing by some other function rather than returning as the HTTP response. I'm looking for some brokered architecture based implementation, and hence my output needs to be returned to a queue for the further processing. Think of an example like the online shopping carts like Amazon or e-commerce portal, I would say, like Amazon or Flipkart or something. When you order something, you actually order via that portal, but the order is going to be fulfilled by a third-party seller. Now, the portal is just going to take in your input and save it until and unless the seller downloads that information for order processing further. So this is what the simulation we want. My input is taken, some local processing that is applicable at the portal level is done, and the final processed message is there for the seller, which is put into the queue. Whenever the seller comes into the working hours and downloads the data, his functionality then can take over and read from the queues and process it further. Okay, so that's the simulation we are looking to have. Our first function, just assume that it's the e-commerce portal taking in input and writing that data to the queue for the seller. So here we already have the queue, demo queue created. There is no message as of now. I'll go back to the previous tab. And here I need to make some configuration which makes sure that the output of this function doesn't go as a HTTP response, but gets written to the queue. So what I do here is I go to the integration configuration on the left-hand side. There, I see there is output binding already configured, which is configured to return the HTTP response. This HTTP $return actually suggests that. If I click on that, it actually shows me binding type is HTTP, response parameter name is return. This is something which I want to get changed. Here, the drop down is not allowing me to select anything. So I simply click on delete. And I'll create a new output binding over here. So you can see the default output binding has been deleted. It says no output bindings defined. I click on plus add output. There it allows me to select whichever output binding I want to select. So multiple options. I have Twilio SMS, SignalR, SendGrid integration, HTTP, which was there by default, Azure Table Storage, Service Bus, Queue Storage, Event Hubs, Cosmos DB, and Blob Storage. This list will grow in future. For now, our requirement says that we want our output to be written to Azure Queue Storage. So I select Azure Queue Storage. The message parameter name that I want here needs to be given. And the queue name also needs to be given. So first I'll configure demo queue here. Storage account connection that needs to be used. I'll say use this default storage connection that is configured for the function. While creating function app, it asked for the queue parameters, right? And then the message parameter name, I'll put $return and click on OK. Fine. So we change the output binding. Now, one thing to be noted, there can be more than one input bindings. There can be more than one output bindings also. Like if you're looking for multiple outputs to be created and there are different functions which will be reading from either of those outputs, that is also quite possible. You can have chained functions created over here without any issues. Okay. So you can have as many output bindings as you want, and that's why it still shows me plus add output. So apart from putting it into storage queue, maybe if I'm looking to upload to blob storage, I can do that. If I want to write it to Cosmos DB, I can do that. If I want to write to the service bus queue, I can do that, and so on, right? So n number of output bindings along with n number of input bindings are possible. So here, this is done. I just go back to code plus test and once again try to test this function. So here we go and click test run. Our input is already set. The HTTP method is also set to post already. And we just need to click on run to test it, to trigger it. Wait for some time. This time we don't expect any response being displayed here, but this status code 200 OK is important for us. This says that my request has been successfully processed without any errors. There is no response I'm sending, hence it is not coming here. That response must have been written to the queue. Let's see. We have the other tab open already over here. And here I just click on refresh. And I can see the message text has been displayed over here. If I want only the value that is 30, what changes I need to make into the code? Instead of saying new OK object result, I would just say return response message. The queue has got one message already into it, and we achieved our next target as well. The next thing that I'm looking to do is get this particular message processed. And for that, I want another function to be created. That function I can write straight away on the portal, but then, as I said, if I have some complex requirement where I want this data to go into a database via entity framework or something, I may have lots of packages, NuGet packages on which my function will depend. And the dependency management in portal is little indirect. There is no way here on the portal where I just put my requirement like install this package and the package gets installed in the working directory or something. There is no automation also available. So for such requirements, usually we go for Visual Studio. Let me launch Visual Studio. I'll take a new project here. I'll look for cloud category here under C# language, all platforms. And there we have the option for Azure Functions. I just select this, click next. I'll name this as OI demo function app. Okay. Prefix VS underscore is also there to denote that this is created in VS. I put this on desktop and create. Here it gives me the different templates I might like to start with. And different triggers are also there. So by default, it gives me HTTP trigger and all. I can probably select this HTTP trigger option. Then it is asking me for the storage account. I want the existing storage account to be connected. So I just click on browse. Logs into my subscription account, detecting the subscription. So this is the one. It detects which all storage accounts are there. So it is this OI demo storage. I select this and say add. Authorization level I keep as function. I click on create. So these are same kind of inputs that we give directly on the portal. And there comes our sample function, which is pretty much the same. Here the configuration is right away there in the form of the attributes, where we have the get post requirement automatically set here itself in the attribute HTTP trigger. If we want only post to be used, we can remove get. If we want only get to be used, we can remove post and so on. Okay. I need to give some name to this class function one. I'll name this class as, just go to Solution Explorer, right click function1.cs and say rename. Name this as demo function app in VS. That is Visual Studio. Host.json contains your app settings, just like app settings.json in normal .NET Core applications. You can have all NuGet packages installed over here. Right click, add NuGet package, and all that you can do. And it will be packaged as one unit. There is no #r required here. You just use the standard .NET Core practices here and you proceed. Okay. I wanted the queue trigger over here to be used rather than HTTP trigger. So maybe what I can do is I can just copy this name, delete this file, and I just go for right click on project and say add new Azure function. It will again present me all those templates and all after this step. Here I just paste that name, demo function app in VS, click on add, and now the template I need to select. So here I select queue trigger. Connection string setting name, right now I'm keeping empty. The queue name, I'll go for demo queue and click on OK. So there comes the function mapped to the queue, demo queue. Connection string, it has taken empty, which I'll put it shortly. And then here it is just showing this information. So beside this information being logged, I also want this to be displayed on console when I run this application locally. So assume that this is the processing code at the seller end. Okay. And then I go to host.json. Now you can see there must be some configuration in place. Yeah, here in local.settings.json, it has taken that name. This value for the storage connection string has got a key Azure Web Storage. I copy this and put it over here under connection. I just reuse that connection string and click on save. I want to test this functionality over here. As there is a message already in queue, this should output that message in the queue on the console. So let me say Control F5. I can run this function locally and I can test it just like a console application. Let's say allow access. And see here the output comes. This is what the message which is there in the queue. Now the next question is, how do I deploy this function? Okay, the deployment goes this way. If all well, if the testing is successful, all of your test cases that you might have created are all successful, finally you want to get it deployed. So just right click on the project here in the Solution Explorer and say publish, just like app services. It automatically finds that it's an Azure function, not an app service. Hence, the UI over here is quite different, where it is asking you whether you want Azure Functions consumption plan to be used, premium plan to be used, or service plan to be used. Service plan, this represents Windows based, this represents Linux based. Both are actually otherwise same. Just the target OS is going to be changed in these two. This is Windows, this is Linux. For now, we will go with Azure Functions consumption plan. As we saw, this represents the serverless functionality. And I have options like whether I want to deploy to an existing app service, Azure Function service, or I want to create a new one. So for now, I'll say create new, though I can choose the existing one as well. Just to show you that, okay, the new can be created from here as well. I'll go for create new. And then there is a checkbox run from package file. So by default, all of your deployment is packaged as a zip file. that zip file gets uploaded and all of the execution happens right from the zip file. If any changes required, you have to come back to Visual Studio, you have to make those changes, you have to test those changes and repeat the deployment process once again. So let's say create profile. We'll ask for a few details like by what name you want to get it deployed. This needs to be globally unique, so I'll go with this where it has taken the name of the project followed by the timestamp, subscription taken, resource group automatically taken. If not the correct one, you can change it here. You can create a new resource group also if you want. Then the location I'll change to Southeast Asia. That's the last one. And the storage that I want to use here also needs to be selected. So I select OI demo storage that we created for this demo. If this function is making use of some SQL database, I can create SQL database from here. And again, if any additional storage account, if I'm looking to use, I can create from here as well. And then I click on create. So this will get the deployment done on Azure account in the subscription. Consumption plan based Azure function app will be deployed by the name that we have given here under this subscription, under this resource group on this location. Should be completed in a few more seconds. So right now it has created the profile for us. I'll just click on save and click on publish to finally publish our code as a package. So this also should not take much time. Within next few seconds, it should be over. It says publish started here. If you want to see the details, what is going on, you can open the output window wherein it actually puts all the logs. Anyways, right now it says publish succeeded. That means there was no error publishing this application. And I go back to the portal on functions. On the left hand side, I have the shortcut already created for function app. I just click on that. Shows me all the function apps deployed in my subscription. So here I can see the new deployment that has come in. I click on this. The new URL automatically gets generated for me. If I click on functions here, I can see demo function app and VS is already there. And then here, if I go to code plus test, only configuration gets displayed, but I can still say test run, though it is queue triggered. So I need not actually say execute. I just need to put a message in the queue, and the moment the message arrives into the queue, automatically this code will execute. This is now automated, queue triggered. Right, so functions showing me the function here. So this is where we actually have a demonstration where we have two functions running as a chain. I trigger one function and the other function gets triggered on its own. So the chained functionality also we have built. The dependencies are there where this demo function app in VS now depends on our previous OI add func. And when the add func actually executes, it puts the data into the queue. And the moment the queue gets the data into it, this function automatically gets triggered. But this is a loose coupled dependency. This is not a tightly coupled dependency. Why I said that? Because this function is not depending on the other function. This function depends on the message in queue. Now, it doesn't matter whether the queue gets the message from the other function or that message has been put into the queue directly by some other application, or maybe here I can say add message as well. So in all cases, whenever the message gets added here, the function, this one is automatically going to be triggered. So hence it is a loosely coupled architecture. So lots of complex situations we can actually create by dividing all that complex requirement into small pieces to make them simpler tasks. And each simpler task can be a Azure function. And then the function chaining can be done pretty easily. Now moving on to the last part of this particular session, where we are going to see the Azure durable functions. Now what durable functions are? Like we used to have web jobs, some background worker process being executed behind scenes. And when we say background worker is there, definitely this must be a pretty time consuming stuff. And that's where durable functions come in. Always the logic apps may not provide me the solution, as I was talking about some complex requirements where the complex logic processing needs to be done. So in that case also, if I'm looking for chained functionality, something what we call as fan in, fan out, something what we call as chained functionality, multiple patterns are there for this stuff. We actually need to have a workflow only to be defined, but we want it to be a completely custom workflow defined in the form of code. That's where Azure durable functions come into picture. So let's say there is an entry point, then there are some intermediate activities, and at last there is some functionality which produces the output. So if this is what we are looking for, also in between we are looking for some functionality which gives me the tracking information. What is happening, where the status is, what is the status of the request that I've put, like I have applied for loan, and what is the status of my loan application I want to check. This is definitely going to be a long running process, which may go on and on for few days, few months also at times, right? And lots of human interaction will be required in between as well. One function called, that function says that, okay, I need more input, gives a notification back to the application, where application, if it is a web application or mobile application, just receives a notification. Whenever the user logs in, he gets that notification, clicks on it, and then the new UI gets created where he gives that additional information, additional input, and then once again the flow starts. So if this is the case, the human workflow kind of implementation, and in a very complex manner, need to be implemented using code only. Whenever this is required, we go for durable functions. And how do we create? Durable functions cannot be created directly on the portal. For durable functions, we need to take help mandatorily from Visual Studio, because it represents a complex scenario. For complex scenarios, we said already that it's the Visual Studio that should be used. So we'll go back to Visual Studio, and I'll go for a new project here. Once again, I'll select Azure Functions, click Next. I'll name this as OI Demo Durable Functions. Desktop is the place where I'll put it, and let's say create. Here I'll choose the empty template, because right now the trigger list doesn't give me anything about the durable functions. So I click on empty. Storage, I'll use the same one which we have already created, OI demo storage, instead of creating a new one. Click on create. Almost immediately it does that. Local.settings.json already has got the connection string and all for storage account. Any other app settings you can put in host.json. Anyways, while deploying, these two files are combined and deployed as one. And then I right click on the project and say add Azure function, new Azure function. Let's name this as durable func demo. and say add. Here we can see there is a template for durable functions orchestration. Let's select this and click on OK. So by default, it has given me some implementation as a sample, starting with the function run orchestrator. Then we have something called as say hello. Then we have something called as HTTP start. Now this HTTP start method represented as durable func demo HTTP start to the client is basically the entry point, or you can say the triggering function. The request has to come over here. That's why you can see the get post is configured here. As a HTTP request, the request has to come to this function. And what this function then is doing is starting a new process over here in asynchronous manner, because it's a long running one. So definitely it has to be started as a worker thread. So it makes the call to another function called as durable func demo. And then some logging and check status response and all information is there. This status response is actually going to generate the trackers for me to check at what state my call right now is in. So this durable func demo is this function, which is mapped to the C# function run orchestrator, wherein we have a list of string by the name outputs created. And probably this is because my run orchestrator function is going to make calls to some dependency functions, which are going to generate outputs from various places. And all those outputs I want to collect into one list. And as the result of this particular run orchestrator function, I want to return all the outputs from all the dependent activities. So that's what it is. And here you can see we are saying outputs.add. The response from call activity is saying there is a call to another function with the input as Tokyo here, then Seattle here, then London here. So definitely here what we are looking at is three different function calls being made to the same function with different inputs. And we can actually replace this with different functions with different inputs as well. And whatever the response that comes in, that gets added to this collection. Now this function, if you see here, it's taking in name. First time for first call, Tokyo comes in, for second Seattle, for third London. What we are doing is we are just logging that name and returning the hello message. So the result of this function call will be hello Tokyo, that gets added to outputs. The result of this function will be hello Seattle, that gets added to this outputs collection, and similarly hello London for here. And then finally this one also returns. Okay, so this is where we can see some function chaining happening. The input comes here, then it goes to this, then it further chains to some three different functions. To keep it simple, right now the same function has been used 3 times, and then finally the output gets returned. So here the sample also is displayed. This is the sample output that we will be getting from this durable function call. Now overall setup represents one durable function only here in this case, right? These are all sub processes, we will say. The actual function is this, where the get request is going to be deposited. So let's test this. Control F5. This will start the local host. This is the URL where I need to deposit my request, either as get request or post request. I copy this URL, select, and from this menu, edit, copy, and then I open Postman. I close the existing tab, clear all the previous requests, and click on plus, where I put that URL copied, and I click on send. So this triggers the execution, and now that status is being returned from that function as per the code. The status response is coming, and that response is visible over here if you see. Three different URLs it has given: status query get URI, status send event post URI, and then terminate post URI, and purge history delete, and so on. So I'll click on one of the URL here. Let's say status query get URI. I click. It creates another request over here where I click on send. Here I see the actual output. Hello Tokyo, hello Seattle, hello London, because this is something which is status query, and that's the actual status, right? Here I'm sending intermediate events and the request for terminating the request and deleting the history. So different operations have been configured for us. When I click, when I request the status, automatically the intermediate output also comes in, right? So complete workflow scenario without using the workflow tools like Windows Workflow Foundation or the logic apps. Totally, the workflow has been defined with the help of C# code, or maybe VB code if required, or F# code if required, and that is what will be deployed. So now let's see how do we deploy this. The process is pretty much the same. I just right click here and say publish. Consumption plan is what I want to use. Let's say create profile. Storage, I'll change to UI demo storage, and location will be Southeast Asia. Rest all is fine. Click on create. This will take a while to get the profile created. Meanwhile, we'll just go to the portal and keep our function app portal ready. Pretty soon we will be able to see one more deployment here. This process has to complete for that. Okay, so profile has been built. I'll click save, go back to portal, refresh. I should see a deployment here. Okay, let's complete the publish process here. Yes, here it is. It took some time. It is this one, UI demo durable functions with the timestamp. Functions will be listed here as well, all the three. Right, so here we have the HTTP request function, that is the front end function or an entry point. Then we have orchestration function, and then the actual activities that are doing the actual job. Right, so this is creating the workflow, and this is just the individual activity. So within Visual Studio also we can actually see that once again. This is my entry point. This is my orchestration function that builds my workflow, and the say hello that is being used here via this call, which is mapped to say hello only. This is my individual activity. Okay, so it's deployed. And here I just click on this HTTP start function, which is my entry point. Click on code plus test. Click on test run. I'll put a get request here. Click on run. So here also, just like Postman, it has given me different URLs as the response. That is the status check response. I copy one of the URL for status query get URL. And open another tab, paste the request here. Oh, it didn't copy. Yes, so that's the one. Press enter, and here we get the same response. Okay, so basically the interaction with these functions will be always done by some Ajax queries and all, maybe with the help of jQuery or plain vanilla JavaScript or modern JavaScript frameworks and libraries like Angular or React, and they will be processing this output, intermediate output as well. This is where we are just looking at the server-side implementation. That's why within browser, the raw JSON data is visible. But once you have the complete application in place, you'll be reading this JSON data and processing it and making it user readable and then displaying it into the UI. Right, so that's what basically the durable function is and how it is created and deployed. What we have learned today is what is serverless architecture, how it helps us. So that is what where we ask the question, why serverless architecture? Then creating the function, setting up the input output bindings, setting up the triggers, followed by how do we create the function app using the Visual Studio, and ultimately implementing the Azure durable functions.